Yes. Can you hear me? Here. You guys? Yes. So, what's your name, sir?
Brian.
Brian? Oh, Brian. Let me see. I think I have something for you, Brian. Yes. One message. What does that mean? Hi. How are you? Are you happy?
Sure.
Yes, we are happy. Let me see. Two happy people. Yes, to you. What's your name?
Jason.
Jason. Thank you, Jason. All right, let me see. Are you happy?
Oh, yeah.
Good for you. Okay. Let me see. What's your name, sir?
Stacy.
No. Okay. It's a secret. Okay. All right. Let me find out who is here. Oh, I think I got something for you. John?
Alan.
Alan, of course. Yes. Alan, this is for you.
Thank you very much.
All right. You're welcome. I think I know you. Let me... Jeffrey. Yes, my friend. That's for you, Jeffrey. Okay. Oh, I know you, Jeremy.
Yep.
Yes. Are you okay? You're happy too?
Happy.
Happy. Everybody happy. Let me see. We cannot look inside, right? All right. That's for you. Let me see if I have some more here. Oh, there's one guy here that I really know. How are you?
Fine.
Okay, this is for you, brother of Daniel. Okay. Oh, let me see. You, sir, I know you too. Young? Yes. This is for you. Thank you. And the last one. It's for me. No. Oh. Are you okay? How are you doing? Good. All right. Mark. No. John. No? Help me. What? Thomas. Thomas. Yes, this is for you, Thomas. Thank you very much. All right. So, actually, I forgot something. Where is that thing to change the slides? Oh, all right. Where is that? Let me find it. Could someone help me here? I don't know where is that thing to change the slides. Whoa. This is part of the show, okay? All right. I don't think so. Where is that? Okay, so. Who am I? I'm the mailman from Brazil. My friends. Why? I don't know how to use this. I still need the thing. I think this is this big one, right? Okay. What have I just done? I have delivered some message, right? So, let's suppose you are going to return all the message to me at once, right? Everybody together. Another question. How many hands should I have to receive all the message at once? And more, it's not just about receive the message, all the message. It's about processing the message. And you're gonna like this. How many mailmen should I have to process all the data? For how long? And when do I need those mailmen? All of them are my brothers from Brazil. The second one is me. You can see. Yes. Okay. So now that everybody's happy, that's the last session of the day, right? After this is party. Okay. Who am I? I'm a solution architect. I work in Latin America team. And what we are going to do here in this session, we are going to design and build an application that could handle any volume of message in this session, okay? So it's a challenge because I'm gonna do that live, so. Okay, let's see. Okay, what is the scenario? Super Bowl, and we are going to have a promotion. Who is going to win the game, the match? And this promotion is gonna be based on SMS. So I send the SMS with the name of the team that's going to win, like Team A or Team B, okay? That's the idea. Requirements: we cannot lose any message. We need to process all the valid message. We need to log all the invalid message and errors. We need a beautiful dashboard, and we're gonna deploy it today. And, really important, we must process all the message during the event. We cannot say the winner is Thomas after 1 month, right? It has to be in the end of the game. Okay, so who is going to be in the front line? It needs to be fast. It needs to be scalable, right? Make sense? Okay. It needs to be reliable. And I want it simple. Simple, full managed service, simple, queue service. Awesome, SQS, right? Okay, that is the first thing we're gonna add to our architecture. So, why SQS? Because it can handle any volume of data, any level of throughput. We cannot lose any message, and that's why we're going to use SQS. We don't need to spend money up front because we are using it as a service. And here we go. We have the SQS in our architecture. Now, we have all the message in SQS, and now we need to process. Let's see how it's gonna be. So we have many instances, many servers. But the question is, how many instances do I need to process all the message? Before I answer that, let's see something interesting. Each instance is going to run many threads. Why? Because we want to use as much as we can of each instance. Because then we reduce the cost and we increase performance. Make sense? You okay? Liking? Okay, cool. So we have many threads on one instance. Okay, so this is our architecture. Do I have a laser here? Oh yeah. So we have here the workers and each worker with multi-threads. Awesome. But I didn't answer how many instances do we need. Let's do some mathematics. One instance can run 100,000 messages per minute. How do I know that? Because I've been running some tests, and I know my application, and I find out that if I use M1X large instance, I reach 100,000 messages per minute. I have to run this test, and you have to run this test in your own application. You have to understand your application behavior. So 10 instance, 1 million message per minute. 10 instance, 5 million message in 5 minutes. Now we know how many instances we are going to need. But let me ask you something. Do we know how many messages are we going to receive? No, right? So what we are going to do is we are going to create an auto-scaling group that is based on the number of messages visible in the queue. And we are going to set alarm here that says, if the queue has more than 5 million, 6 million, or any number you want, add more X number of instances. So if you receive more message, you have more machines. If you don't have too many messages, you don't need those servers. Make sense? Is okay? Are you recording? Yes. Yeah? Oh, no? YouTube. You shouldn't do that, I think. But anyway. So we should, then we process the data, and what are you going to do with that data? Be polite. What are you going to do with that message that we have in our hands? We need to save the message. What? To save the message, exactly. Now we need to save, and we need a high throughput to save because we have many messages arriving. So who is going to be the service that is really awesome for that? DynamoDB. Cool. And we're going to have two tables, valid votes and invalid votes. Make sense? Valid votes to valid votes, invalid votes to invalid votes. Simple. Okay. So this is our architecture. SQS with all the message, auto-scaling group for the instance, and two tables in DynamoDB. Next, we are going to build our dashboard. And our dashboard, yes, it's beautiful. It was designed by one great architect from Amazon. You know who, right? Okay. That's our dashboard. We are going to deploy it later. It's going to be okay. So in the end, we're going to have, after the DynamoDB, we're going to have the dashboard reading the message or the records or the data from DynamoDB. And take a look at this green icon over here. It means we're going to use beanstalk to deploy it just because it's really good and make our lives easy. Okay? All right, so the benefits of this architecture, let's see. I'm ready for any level of throughput. I'm ready for any required SLA. Why? Because if I need to process all the data in a short period of time, I can add more machines. And low cost, because I'm using full managed queue service. The infrastructure is based on the required SLA, and I don't need that infrastructure after the event. Right? I just stop it and done. Cool. Okay, the challenge is I'm going to do this live. I'm going to process 10 million of messages in 5 minutes. Actually, I'm going to process 20 million of messages in 10 minutes. Is that okay? That's okay? Okay. So that is the challenge. So let's go deep, and let's do some code, and let's deploy this architecture. Let's understand something. Each thread is going to connect to SQS. Then it's going to read up to 10 messages. Then it's going to validate the message. This is my business logic. I just validate if it's in the right format, and that's okay. And I'm going to save as valid or invalid in the DynamoDB. After that, I'm going to delete the message from the queue. Okay? Right. Good thing here, as we're using SQS, So when I read the message from the queue, it's not visible anymore to the other workers. And I can set a timeout. If I can't process that data on that timeout, or if anything happened, the message becomes visible again. Okay? Right. So, let's do it. Let's build this. So now it's the moment that I have to switch to my notebook, and let's see if it's working. All right. Here. Okay, here. Oh, I have to push something here. They said it's written Mac. Let's see. Yes. The password, everybody knows. The beautiful architect. 1, 2, 3. Yes. 1. Don't you agree? Come on. Okay. Let me open the PowerPoint here. And let's go step by step, and let's see what happened on each step of each thread. Okay. First step, connect to SQS, and then read up to 10 messages. So I'm going to move to my Eclipse. Can you see it? Okay. Here, as you can see, I've already installed the plugin to Eclipse, and I can see all the service, right? So if I go here on SQS, I'm able to see that I have already 2 queues, one for tests and one for production environment. Let's open this one. And I have here some samples, right? The data, the sender, the ID. And you can see that I have here around 2 million messages. This is my queue that I use to test. And DynamoDB tables, I have the valid votes and the valid votes and just 2 others to test. Awesome. Okay, so let's see the code. I have 2 projects, the dashboard and this name that I like it, Reinventor Message Processor. Okay, so let's see the main class of this project. And is that okay to read? Okay. First thing, I'm going to get parameters from the environment. And this is really important because I'm dealing with many instances. And I want to be able to change the behavior of the application when it starts or maybe on the fly. So it's important to have parameters. Okay? One of them is the number of threads. Okay, so here on this line, I create, and this is Java, okay? I create the thread pool of a specific number of threads. And after that, I just create one loop, and for each loop, I create my thread right here. This is the class that is running the thread, okay? So let's open this thread, and let's see what is happening inside of it. The thread has a method called run, because it runs, exactly. Walks? It depends on the instance, right? I'm kidding. Okay, so it's really simple. Don't judge my code, okay? Please, it's just a demonstration. So inside the method run, I have like an infinite loop, and the first thing I do, I read the message from the queue, and then I process. Cool. So the first thing we have to see here is how I connect to the queue. So let's open the service layer. I have a service layer. And I create right here, really simple. I'm using properties file locally. That is not a good option. I could use IAM roles. It's much better. But as a demonstration, I'm using the properties file. Okay. And then I create, this is AWS SDK already. Amazon SDK client with my credentials, and I set the endpoint, and take a look, again, it's a parameter. And this is important. We are working with a high volume of message. It's application that we want to change the behavior. It's important to have parameters here. So yeah, this is the connection. So let's go back to the task, and let's see how it reads up to 10 messages. It's really simple. I create, again, this is SDK. I create this object, receive message request. I set the queue name, and here I set the max number of messages. And then, simple as that, I call the SQS client. In the SQS client, the method call it receive message, and I use the message request. And I get the message as a list. Done. I have the message. Let's see the next step. The next step is validate each message. So let's go back to the task and process message. This is my super complex business logic. For each message, I just validate if it's in JSON format. And then I save the vote if it's valid, or if it's invalid, I save as invalid message. Let's see the next step. Next step is save as valid or invalid. Let's see the code to do that. So here, I'm going to open the save vote method. And here I create a map, key value, a hash map. I fill the map with the JSON object. And really simple, this is my code, and this is the SDK. I create the object called put item request. And the parameters are the name of the table and the item. And I call the method DynamoDB put item. Done, it's there. Let's see the next step. I have to delete for real the message from the queue. Let's go back to this guy here. So here I save as invalid. And at the end, if everything is OK, I set the message processed. And I create the delete message request, the queue name, the receive handle. Each message in the SQS has an ID, and I use this ID to remove it from the queue. And I call the method on SQS, call it delete message, and I use delete request. It's done. It's ready. 4 classes in Java to do this job, okay? So let's see how does it work in my machine. I'm going to run this class, that is the main class. But as I'm working in the test environment, I'm running it against the queue test. So let's run it. Run. It's going to be ready right here. So let's see on the web administration tool what is happening. So here I'm logged in, and I have the same 2 queues we saw at Eclipse. Let's refresh this. Oops, it's reading the wrong queue. Come on. Let me change that. Sorry. Let's change that because, you know, it's called queue test. Is that correct? Did you remember? Thomas, did you remember the name of the queue? Thomas? No? It's queue test. You are not listening to me. Come on. Queue test is the name of the queue. So let's go back here, queue test. Let's run again. And see why it's important to have parameters hard-coded? Let's see. Okay, here we go. Queue test, and we have message in flight because I'm consuming, and this number should decrease. Awesome. So, the application is ready. what is the next step? We have to deploy it. First, let's see another interesting thing about the dashboard. The dashboard is just a web application, and as I'm using the plugin on Eclipse, I can just do it like this, Amazon Web Service, deploy to Elastic Beanstalk, and I can choose my environment over there in the cloud and just deploy it. I've done this already, okay, because it takes some time to upload. And let's see how it is here. This is the dashboard, okay? We're gonna see a little bit more about this in a few minutes. Dashboard is here, it's running, it's green. I have a URL, and if I open it, here we go. Okay, we're gonna see more about it in a few minutes. Okay, so let's see the steps to deploy all of this. You can see probably. Why? Let's go back to the other one. Let's see. Wait. Okay. Cool. So we have to create the queue. We already have done that. And we have to upload the application to S3. I've done that. Why do I have the application S3? Because every time a new instance I launch, this instance has a bootstrap script that downloads the application from S3. It means if I update the application, I don't need to update the image or the servers. I just call one script and it's done. It downloads from the S3, okay? Right. Next, I have the image ready with the Java environment, ready to run. And the ID is AMI something. So the next step is, let's create this bootstrap script. Let's see how it is. This is the script. Can you read? Okay. This is just a shell script. So I go to the EC2 user home folder. I download the Java application from S3. I set the parameters, number of threads, DynamoDB table, DynamoDB invalid table, queue name, and I run the application. Okay? This line over here, I'm just calling the application, okay? And I'm redirecting the output to a log file. Just simple as that, okay? So the script is ready. So if the script is ready, the next one is create launch configuration. What does that mean? It means we're going to start to work with auto-scaling group. The launch configuration defines the kind of instance we want to run the application. Small, micro, large, right? And the image we are going to use. So let's see how we can do this using command line. Yes. Okay, so I have here my history. Create, launch. Let's see, can you read this? Is that okay to read? Okay, so the first thing is AWS auto-scaling command line. The next is create launch configuration. The launch configuration name is reinvent LC. Daniel, right? Daniel. What does that mean, LC? Launch configuration. Reinvent launch configuration. Instance type, M1X large, image ID, that image, and my local file with the bootstrap script. And the key name I want those instance has, because if I need to access some instance, I want to SSH on that specific instance using this key. So let's launch it. Let's execute. Okay, this answer is good. Okay, it's done. It's there. So the next step is let's create the auto-scaling group. So AWS auto-scaling, now create auto-scaling group. And auto-scaling group name, reinvent ASG. Daniel, what is ASG? Well done. And launch configuration name, the one we just created. And now, it's really important. Really, really important. I'm going to set the min size to 5 and the max size to 20. It means that right after this command, as I have the min size of 5 instances, the auto-scaling group is going to launch those instances. Okay? So let's run it. What? Okay. Where are the instances? I'm going to show you. And I need one policy that says that when I go up to specific number of messages in the queue, I trigger that policy to add more, example, 10 machines. So let's create this policy. And I hope I have it here. Let's see. Policy, no. Let me copy from I have one text here with all the commands because I don't remember all the commands, okay? Don't be angry with me. Let's see. Commands to reinvent, and here. Put policy. Okay. And the policy, the command says AWS auto-scaling, put scaling policy, policy name. Read this, add 10 instances. Do not forget about this name, add 10 instances. And the scaling adjustment is add more 10 and change in the capacity. It could be set the exact number of instances on the auto-scaling group. But here, I'm just adding more 10 machines. And of course, the auto-scaling group name, reinvent ASG. I think it worked. Let's see. So if I'm right, we should see, I have 2 images here running. Let's refresh this. Whoa. Huh? Yes. You like it? Come on, come on. Yeah, it's working. Yeah. Okay. So now, but only 5 instances is not enough. Let's create the trigger, the alarm on CloudWatch. Okay, let's create the trigger. This is the CloudWatch environment. I'm going to create a new alarm, and I'm going to say SQS. And I'm going to choose my queue, call it votes, and the metric I want is number of messages visible. Make sense, this name? Yes. And as soon as I click here, you can see this chart showing. I've run some tests today, in this morning, because I was afraid, you know, it's live. So it worked, as you can see, in the morning, it was working. So here we have 20 million messages. Okay. So let's create the alarm. Let's call it alarm to add 10 instances. Beautiful name. Just a description. I'm going to remember this, of course. And I'm going to set here if the queue has more than, and take a look at this red line here, 2,000, 2 million. Is that correct? Yes. Take a look. Ta-da. Now, if I have more than 2 million messages in the queue, I want to auto-scaling action. And I'm sorry, I'm going to reload this page. I'm sorry, I forget about it. I have to reload, okay? Just a minute. Yes, create alarm, SQS. I'm doing this because you need to remember this. That's why I'm doing this twice. Okay, and then saw this, next, okay, add 10 instance, just description, more than 2 millions, and I hope, where is the reinvent? Yeah, here we go. The group I want is reinvent, ASG, and remember the policy? Look, the policy is here, add 10 instance. Cool? So I'm going to create this alarm. Okay. So let's take a look if all the instances here. Yeah, the 5 first one is right here. I just created the alarm. It's going to trigger in a few minutes. Let's take a look at the queue if something's happened on this queue right here. Yes. It's reading already. Those 5 machines are reading the queue. Okay? But it's not that fast. Take a look, just 3 million, around about 3 million messages. Okay, let's take a look at the dashboard. And let me go back here and Beanstalk. I have the dashboard here. This is a good thing. Here I have my applications, and my application is called dashboard. And here I have this block, this green block here. It means I can have 1 or more environments, like development, production, test, development, right? So I have this one here, and it's okay, it's green. Let's open it, and let's see. It's just doing an AJAX call. Let's take a look here if it's working. It should change here to the percentage of the votes. Come on. Yes, it's calling. And yes, here we go. We have the answer here and 50-50. Okay? Cool. So this is the dashboard. So now, while we wait, let's just see if, yeah, take a look. CloudWatch rocks. Okay. So while we wait those machines be ready, I would like to invite to talk to us about what they are doing with SQS. One company called it Big Data Corp, and they are awesome. They are doing pretty good stuff, crazy stuff actually. And Toran, yes, please, welcome. Yes. Thank you very much for coming.
Hello, okay.
Thank you.
How are you?
Oh, I'm fine.
Okay.
Go ahead.
How's everyone? Okay, so first just give a little bit of background on our company. We founded the company about 3 years ago or so, and we were lucky enough that no one's talking about big data, so we managed to get the name and get the domain and so on, which is a great thing. And we've been doing a lot of work with big data since we were founded, and the way we see it, big data is a process that runs through data collection, data cleaning, and so on and so on and so on. And we developed services and products that address each one of these steps that we see in the big data process. And we've really, over the course of the years, leveraged existing services, existing AWS services, and services that came up later on in order to deliver this stuff. So I've pretty much covered that, and I went backwards. Okay, there we go. So about a year ago or so, one of our customers came up to us and said, okay, we would like to know, we would like for you to tell us how many e-commerce websites existed in Latin America. And they wanted to see if they could, and our first reaction was like, okay, so you guys are the biggest player in e-commerce in Latin America, and you actually don't know that number? How does that work? But they were like, we don't know. And we talked to a lot of people in e-commerce, and people were saying, you know, we have I don't know how much, 50% of the market, 70% of the market, and we asked them, okay, so if you have 70% of the market, what's the size of the market? How many companies are there? They're like, well, actually, we don't know. And we were, okay. And so we started looking at how we could work in order to answer that question, in order to provide them with that information. And they said, okay, so it's not only knowing how many websites are there, but we actually want to monitor them on a consistent basis, because we want to see they have this logo for the product that they sell, and we want to see how many people are using our logo, how many people are using our products, and how this tracks over time and how it evolves and so on. And so we started looking at the problem from different angles, and we said, okay, so basically what we have to do is build a crawling process that actually visits and monitors these websites and checks everything. But we have to do that in a way that is cost effective and it's pretty dynamic. We needed to do that we started out thinking, okay, so we're going to do this every 3 months. And once we started looking at how the data behaved, we saw, okay, so we actually need to do this every other week and not every 3 months. And so we started thinking about, okay, so cost efficient, scalable, we needed all those things. And I said, okay, I know how we're going to do this. I'm going to get my laptop and run it over the weekend in my house. And that didn't work out very well. And so we said, okay, so let's try and build something a little bit more robust than that. So we grabbed an old server that we had in the back of the closet, and that didn't work out. I said, okay, let's talk to the AWS guys, because we've been talking to them for some time. And so we started looking at the process and saying, okay, so what do we need to do this? And we started trying out architectures and working on stuff and saying, let's try to do this with databases, let's try to do this in several different ways, and it wasn't working out very well. And then we started having these discussions, and we started looking, okay, so perhaps the best way to go about this, and it was really interesting because we were in a meeting with Ari, and we left the meeting. We were discussing ideas and throwing ideas on the board, and we left the meeting, and I turned to one of my colleagues and I said, okay, maybe we should look at this SQS stuff. And at the same time, my phone beeped, and there was this SMS from Ari saying, you guys should really look at this SQS stuff. So I was like, okay, so at least we're on the same page there. And we started looking at SQS, and we started looking at how we could use SQS to really scale our process. Because we ended up using thousands and thousands of spot instances, running thousands and thousands of processes. And once you start doing that, you really start hitting some limits that you don't see in the real world. Like, there's a limit to the number of simultaneous connections that you can open up to databases, and this was actually applying to all databases. Limits on connections to web services, and we tried using standard web services to synchronize stuff, and it wasn't working out very well. So we decided, okay, so SQS provided us a very efficient way to orchestrate our entire process and a very efficient way to actually scale out this process to massively, right? To do all these thousands of images and so on. And we also leverage S3 in order to store all the intermediate data that we need to store logs for the processes and so on. And we really, really use spot instances. We love them. They keep our costs really low, and they really help us out. So after a lot of discussion and a lot of coming and going, this is the overall architecture that we ended up using. So essentially what we have is an orchestrator, which is that machine up there on the top, which we call the Maestro. And that's a reserved instance that's running all the time. And basically what it does is it initializes the process by uploading everything that we need to crawl into a queue. And that's what really gets the process going, because from there, we have a set of main, what we call the main workers, which are different processes that run on spot instances. They are going to be consuming messages from the queue, doing what we call the basic crawl, which is essentially doing the get on the website, loading that HTML code, running some basic processing on it. And then we started chaining the process with additional queues in order to do additional processing on each step. So if I take a website and I identify it as an e-commerce website, I'll ship it off to a queue that's going to have another worker attached to it that's going to do some different work on it. If I identify it as another type of website, I'm going to do something else with it, so I'll put it in a different queue and so on. And at the end of the whole process, once we have the data set, the set of data that we need for each individual website, we'll put it on a final queue that's basically controlling the throughput to the database so that we don't exceed maximum connections or anything like that. That's storing the data on a MongoDB cluster. Another very interesting thing that we were able to do with SQS was to create a command and control queue, which basically allows us to command and control the entire process. We have all of our different spot instances, all of our different worker instances listening to this queue, and we set up sort of a broadcast system where the orchestrator can put a message on the queue, and each instance will read that message and perform some action based on it. And that can be something as simple as reporting their status so that we know how far along a process is going without having to go to the dashboard and seeing how many messages are in flight or still on the queue. Or as complicated as halting the entire process. Sometimes, as we were doing this, we started figuring out that there were times where we need to halt the entire process and go back a couple of steps or something like that. And that queue allows us to send a message that after a few minutes, every single instance will have read it and will halt their processing and can even shut themselves down. So we were able to build a pretty interesting control structure relying entirely on a queue, which ensures that the messages are read, ensures that the messages are processed, that we don't lose any messages along the way, give us all of the benefits that Ari told us about at the beginning. So we ended up creating a very interesting structure there. And just to give you an idea of message volumes that we handle, this is actually from maybe a couple of weeks ago, or it's a little bit old. We've actually increased these numbers a little bit. But basically, we run this process, this entire crawling process every week. And the whole process takes about 48 hours to run from start to finish. We start off with roughly 10 million messages on our initial queue. And each message, as it's processed, may generate up to 10 or even sometimes even more additional messages in order for us to do additional processing. Once again, this can be as simple as performing some work on top of the stuff that we crawled, or it can be as complex as, I need to crawl this again, so let's add it back to the queue. At the peak processing, we actually were now about to 100,000 messages per second that we're processing from these queues. So it's a pretty resource intensive, and we're really taxing the queues in terms of getting messages from them and processing these messages and deleting them from the queues as we go along and so on and so on. And the interesting thing for us about SQS is that it really gave us a lot of resiliency to this distributed process. Because if anything goes wrong with one of our workers and for any chance, and we're relying on spot instances, so someone outbids us on the spot instance and the spot instance goes down or something goes wrong along the way, the message will simply be put back into the queue and we can process it. We can make sure that someone else is going to pick up that message later on and actively process it as we go along. So that's a very useful feature for us to have, because it ensures that we don't have to worry about, was my message actually processed? Did I actually do everything that I needed to do along the way in the process? So it really ensures that. And for us, at least, the command and control queue is a very interesting structure that we've been leveraging on other projects that we've been doing, because it really allows us to adjust the processing as we go along. It can even be used, as I was saying, to shut down instances or to shut down some of the workers inside an instance, or to fire off new workers inside of an instance that's underused. It allows us a very fine-grained level of control about what's going on inside each instance as we go along the process. And it really gives us a lot more visibility than simply looking at the dashboard and seeing how many messages are being processed at any given time. So it allows us to do that, and it's been working very, very well. It's stopped working. Okay. It's just blinking red. Okay. I'll take it from there. So in terms of results that we've been getting, as I said, we've been running this process since January, so about 11 months now. And we were actually able to, over the course of this time, we've managed to process over 3 petabytes of data. And we've visited almost 100 billion different, not different, but almost 100 billion web pages. A lot of times, since we run it weekly, we'll visit the same pages over and over again. But that's a lot of pages, and that's a lot of information to be stored. We've relied on MongoDB to store the data. It gave us some flexibility that we didn't find in other solutions. We also leverage a lot of AWS services in order to control the MongoDB clusters that we need to process the data and so on and so on. But the most important thing for us is that we were actually able to answer to our client how many e-commerce websites were there, what they were doing, which products they were selling, which services they were using. We saw that we didn't need actually to limit ourselves only to e-commerce websites and only to the service that our client was asking us to monitor, but we could actually monitor pretty much everything. And so we built a very, very interesting map of all the today we're looking at all the websites in Latin America in terms of what kind of services they're integrated with, where they're hosted, what kind of technology platform they're using inside their websites, and so on and so on and so on. So we were able to build a very detailed and very interesting set of data that keeps growing and growing and growing, that gives us a very, very interesting view of the web in Latin America, which has been tremendous for our client because they've leveraged this in order to increase their sales, in order to increase their understanding of the market. So it was basically a very, very amazing project. Awesome to work on, to use. I use words, it was awesome. Okay? And that's it. I can't go forward, so I can't show you the graphs with cost reductions and so on. So I can try here. Okay.
No?
Yes. No.
It's frozen?
Mouse is working.
Okay.
Okay, cool. Ha. Some very simple cost estimates without AWS. This is obviously ignoring the fact that we'd have to buy 1,200 servers. We used 1,200 spot instances on our last run. That would take a lot of money. I'm glad we didn't have to do that. But that's just our cost estimates based on electricity and what we need in terms of a support team and so on. So we managed to get very large cost reductions by leveraging AWS services. And looking specifically at being able to leverage spot instances and being able to leverage SQS, we did some calculations and we believe we've saved about anywhere between 60 and 80% of our initial projected costs, especially because the SQS guys, 1 month after we started running the service on SQS, they reduced the price in half and increased message size. They doubled the message size. And we're like, yes, so good. And so that, and once again, that really benefited us in terms of being able to deliver something to our clients in a cost-efficient and in a speedy manner that we wouldn't be able to do so any other way. And okay, so once again, these numbers are a little bit old, and they keep growing over and over. They keep growing each week, which is at a scary rate, but we're at over 3 petabytes of data, over 50 billion web pages that we've visited and parsed and extracted data from and stored. We're mapping almost 1,000 different services and different technologies, and we have over 5,000 dimensions on that can be relevant for segmentation on websites that go all the way from, what kind of website it is and what topic it's talking about, all the way down to the product level. If you look at e-commerce websites, what kind of products are being sold, what prices they're charging, what kind of payment methods they accept. There's a lot of stuff there. Very interesting data. It's been very interesting to look at, and it was very useful for our client. And that's what I have for you guys.